Hello everyone, welcome to today's video. In this video, we are going to cover another topic of testing of hypothesis using HR analytics. That is, we are going to do two independent sample t-test. Using HR analytics, we'll be using HR data to do two independent sample t-test, and I will also show you how to implement two independent sample t-test using HR data in SAS. So first let's discuss the case study that we are going to do in order to do the two independent sample t-test. So before going to the case study, the agenda of today's session is, first we are going to cover the introduction, the primary goals, the concept of two independent samples t-test, and then we'll move to the practical implementation of two independent sample t-test in SAS. Now, let's first come to the introduction part. So let's first understand the objective or the goal of our project that we are going to work. We are going to work on a project based on a soft drink manufacturing company which is manufacturing two types of soft drink, that is soft drink A and soft drink B. And the targets achieved by the employees for both the soft drinks are noted. Now, using two independent sample t-test, we are going to check whether the targets for both the soft drinks achieved by the employee are same or not. So, in order to sum up, we are going to basically check the employee performance in terms of the targets that they have achieved for both the soft drinks. So for this, we are going to do a hypothesis testing of two independent sample t-test, where the null hypothesis is there is no significant difference in the targets for the two soft drink categories. That is, there is no significant difference in the employee performance with respect to the two soft drink categories. And the alternative hypothesis is there is significant difference in the employee performance with respect to the two soft drink categories. The default significance level or the level of significance is 0.05. If our calculated p-value is less than alpha, that is your level of significance, we are going to reject our H0, that is our null hypothesis. And if it is greater than equal to alpha, that is if our calculated p-value is greater than equals to alpha, then we will accept null hypothesis. That is, we will fail to reject H0. That is, we will accept the null hypothesis. Now, the primary goal of our project is we are going to analyze employee performance with respect to two soft drinks. Now, let's come to the objective of our project. Our soft drink manufacturing company is manufacturing two kinds of soft drinks. The target that are completed per month by the employees for each of the soft drink are noted. The manufacturing company wants to check the performance of the employees in terms of the targets they have achieved for each of the soft drink. Now, what are the objectives that you need to attain under two independent sample t-test? First, you need to understand and apply the concept of two independent sample t-test, and then our purpose is to compare the means of two separate groups and to check whether both the means are same or not. If they are same, that is our null hypothesis. If it is not same, that is our alternative hypothesis. Now, these are the certain key terminologies that we are going to come across the two independent sample t-test. That is, your two independent sample t-test has got two distinct groups. There is mu, which is our population mean, that is the average of the entire population. X bar is the sample mean, that is the average of the sample data from each group. H0 is our null hypothesis, which is denoting that the means of both the groups are equal. H1 is the alternative hypothesis, that is the means of both the groups are not equal. And last but not the least is your significance level, that is alpha, which is by default set as 0.05. Now, when do you use the two independent sample t-test? This is another very important point. When you have two separate groups when you have to compare the means of these two groups, and your data has to be normally distributed. These are certain situations where you can apply two-independent sample t-test. Now let's discuss the assumptions of the two-independent sample t-test. The first assumption is samples are randomly selected. Observations in each of the group should be independent, that is, they should not get influenced by each other. Each and every group's observation should be normally distributed, and the variance should be homogeneous. Homogeneity of the variance ensures consistency, so variance should be homogeneous. That is, the data points should be of same type. Now, how are you going to interpret the results? That is, how are you going to take the decision based on the hypothesis testing which you are doing and based on the result which you are getting for two-independent sample t-test. After doing two-independent sample t-test, a value you will be getting, that is your p-value, that is your probability value. If your calculated p-value, that is probability value, is greater than the level of significance, which is alpha, which is by default set as 0.05, then you will accept null hypothesis, that is, if p is greater than 0.05, you will accept null hypothesis, that is your H0, or else you will reject it. Now let's move to the practical portion of two-independent sample t-test, that is, how do you practically implement two-independent sample t-test using SAS. Now we are going to implement two-independent sample t-test using SAS. We are provided with the data of a soft drink manufacturing company, where the company is manufacturing two types of soft drink. The targets achieved by the employees for each of the soft drink are noted. We are going to check the employee performance with respect to the two soft drinks. That is, whether the mean targets for both the soft drinks are same or not, or the mean targets for both the categories of soft drinks are same or not. For that, we are first creating our library. Before you create the library, I have created one folder of HR Analytics, and I have uploaded the raw data file of two-independent sample t-test in my folder HR Analytics. You can create the folder by going to Files and then just right click on it and go to New and create a new folder. I have created a new folder called HR Analytics, inside which I have uploaded my raw data file of two-independent sample t-test. Now I have created the library using my HR Analytics folder. That is, I have executed one libname statement. Libname, name of the library is HR. You can give any name to your library, and then I have given the path of my HR Analytics folder. Because using the HR Analytics folder, I am creating my library. So I am just right clicking on the folder, properties, and from the location I am copying the path. So I am pasting the path over here. So this is my path for my library. So I am executing the libname statement. After executing the libname statement, if you go to libraries, you will find that the HR library is already created. Now my next step will be, I will be importing the data set of two-independent sample t-test into SAS. Now you can import this is a CSV file, this is a raw data file which is a CSV file. You can import the CSV file inside work library or in any other library you want. I am importing this inside my HR library. So I am using the code proc import data file equals to, within quotations I have given the path of my data set. That is my CSV file. So my data set is over here, which I have uploaded inside HR Analytics. So I'm just right clicking on the data set, going to the properties. I'm copying the location of my data set from here. So this is my location of the data set. Now then I'm giving out equal to hr.toSample, because the raw data file or the CSV file that I'm importing inside SAS, that CSV file is getting created inside the HR library. I want to create the dataset, the SAS dataset after importing it into SAS. I want to create the SAS dataset inside the HR library, and the name of the dataset will be toSample. So I've given the name as toSample. You can give any name you want. Out is a keyword to create an output dataset. Then I've used the keyword replace and then run. Now let's run this code. This is my dataset which got imported. Now I want to check the overview of my dataset. That's why I have done proc contents on my dataset. That is proc contents data equal to hr.toSample. HR is my library name, .toSample is the dataset name, and then run. If you run this particular code, you will be getting the data dictionary. That is dataset name, number of observations. Here there are 198 observations. There are 2 variables, the engine, when was it modified, the observations length, the deleted observations. Then the most important thing which you get over here is the alphabetical list of variables. There are 2 variables, one is drink, another is targets. Drink is a categorical variable which is character, targets a numeric variable, the length of the variable, their format and their informats. Now if you want to view the dataset, you can do proc print on the dataset in order to display the data portion of the dataset. So proc print data equal to hr.toSample, that is my library name and dataset name, run. This will display the data portion of the dataset. This is my entire dataset, which has got 2 columns, that is drink and target. Observation number column by default comes in your proc print report. So this is all about your dataset. There are total 198 observations. Now we are going to perform the 2 independent sample t-test on our dataset. So we are going to use the procedure proc t-test data equal to library name dot dataset name, that is hr.toSample. Class is my keyword to specify the categorical variable which is drink over here, class drink. Var is the keyword to specify my analysis variable which is target over here, then run and then quit. Now let's run this code. So if you run this code, you see you got 2 types of drinks, that is A and B, number of observations for each of them. For A is 99, for B is also 99. The mean of A and mean of B, you got standard deviation of both the categories, the standard error of both the categories, minimum value, maximum value of the targets of both the categories you got, minimum value for both the categories of soft drinks and maximum value for both the categories of soft drinks. You got the differences, that is one is pooled, another is sat weight. Now you got the mean, the 95% confidence interval mean, standard deviation, 95% again confidence interval, that is the upper limit and the lower limit. First is your lower limit and next is your upper limit. Next you got, as you know, the most important assumption of your 2 independent sample t-test is that the variance should be homogeneous, that is it should be equal. So here you see when the equality of variance test is done, that is done using folded F test, that is 0.5391, that is your p-value. Now the hypothesis for your folded F test which is done to check the homogeneity of variance is H0 is variance is homogeneous, that is null hypothesis is variance is homogeneous, and your alternative hypothesis variance is not homogeneous. Here since your p-value is greater than your level of significance which is 0.05 by default, so null hypothesis will be accepted. So here the variance is homogeneous. So you will check the method pooled which is considering equal variances. Now see the p-value for your 2 independent sample t-test, it is 0.1312. This is again greater than your level of significance, which is by default 0.05. So you will accept the null hypothesis. That means the mean targets for both the soft drink categories are same. That is our conclusion for our project. Here you are getting the distribution of your target values, which are approximately normally distributed, and these are your QQ plots where the data points for both the categories, that is soft drink category A and soft drink category B, are plotted, and you see the data points are coinciding the 45-degree line. It is approximately coinciding the 45-degree line, showing that the data is normally distributed. So this is all about your two independent sample t-test. So by doing two independent sample t-test in our data, we have concluded that the mean targets with respect to the two soft drink categories are same. So this is all about your two independent sample t-test, and this is how you implement your two independent sample t-test in SAS.